So today we're going to see the difference between gravitation and gravity and acceleration due to gravity. For example, we have two terms like gravitational and gravity. Is just written here as well. There's no need to write it again, but it's okay. So this is gravitation and gravity. What's the main difference between these two terms? Okay, so first major difference is on Earth the gravitational force is gravity, where on the other planet in every part of the universe it's constant. For example, on Venus, Mars, Jupiter, and we can consider any planet, it's just constant, but this value varies from place to place, and even on the Earth vary from one place to other place until we consider this value on the surface of the Earth, right? So what's the difference between gravitational and gravity? Now we're going to consider two masses. This is mass 1, this is mass 2. Now here's the body, mass m, placed on the surface of the Earth, and this is the center of the Earth. So center of the Earth attracts this body with the force mg, and these are two bodies, body 1, body 2, m1, m2, and this attract each other with the square distance between their centers. So one is the one is their mass is placed on the surface of the Earth, and the Earth attract body with the force mg, and other is two bodies attract each other with the force square distance between their centers. So we're going to compare these two values, which is F is equals to mg, right, and G is equals to m1 m2 upon r square. Or we're gonna take like this, F is equals to mg, I'm sorry, it is F, and here we're gonna get G. Okay, so this is mg is equals to G m upon r square. R m cancel with m, and now we have a value of G, which is G m upon r square. And the one interesting thing that I'm gonna tell you here is that this value of G varies or dependent on G constant, mass, and distance. Actually, the value of G is inversely proportional to the distance. If we increase distance twice, the gravity decreases 4 times. So it's a square concept. If we increase distance 3, it decreases 9 times, right? So we can take a square, simply square for to get the value of G, how many times G increases or decreases. Okay, so this is a simple concept. Now, but if the body, this is the Earth, if the body is placed here and the Earth attracts the body at the center of the Earth, so here the value is G is equals to G m upon r e square. Here the value of r e square is constant, which means it is on the surface of the Earth, and it is 9 point, and you're going to get the same value if you're going to solve this equation by this method. I'm going to show you this. Now you're going to put the value 6.67. It is the value of the constant G, and then the mass of the Earth is 6 multiplied by 10 to the power 24 is the approximate value. We can write 5.9 as well. This is the radius of the Earth. If we're going to put this value, we're going to get the answer. This is 9.8 multiplied by not multiplied by meter per second. Acceleration square, meter per second square. So this value and this value is entirely different. Remember one thing, small r square means it varies. The value of gravity is dependent on G, m, and r square, but here the value of G isn't dependent on G, m, and r square, because the value of r square is capital, and it means it is on the exactly, here you can see, exactly on the surface of the Earth, and it does not vary from place to place. However, the value of gravity is not constant, but the approximate